Okay, we give you the average cost per item and ask for the total cost. So the total cost is the average cost times how many items. So you just pump up this exponent on each part of this polynomial. Very straightforward. Find the derivative of the cost function. That's easy. So we go ahead and do that. Okay, I happen to have an answer key that I previously prepared, so this is why. I mean, if you had a calculator, you just go 2 times 2.94. I wouldn't bother doing that in my head. Okay, at what production level is average cost a minimum? And so we have to first find, where's the average cost a minimum? So we want to minimize this guy. So for the moment, we pretend that we don't know that that comes from anywhere else, just out of context. So I'm going to just rewrite average cost so you can see it down here. And plus 1700. So we want to take the derivative of average cost. Now you remember normally this thing is a parabola, and then I say, just find the vertex. But I purposely made this not a parabola so that you have to actually go through the normal standard calculus routine to get the answer. Take the derivative, set it equal to 0 to minimize anything or maximize anything. Take derivative, set equal to 0, solve for independent variable, in this case q, plug answer back into function. Okay, that's what you always do whenever you want to minimize or maximize anything, right? And if you have multiple points at which the derivative equals 0, you have to figure out which one is the min or which one is the max. Okay, so in this case there's only a single candidate, or there's two, but it'll be obvious what's going on. 2.94 divided by 0.06 is actually the same as 294 divided by 6. Doesn't matter, you can just do either one. You get 49. This was rigged to work out. On one version of one exam I tried to rig it to work out and it failed. So this should come out even, but if it doesn't come out even, it just may mean I planned the question and it flopped. So sorry for that. Okay, so now the q is equal to -7. Obviously we only care about 7 because we don't want a -7 items. And so average value at 7 items is oh, it says at what production level. Okay, so actually this is split up into two. If it said minimize average cost, then C and D would really be one question. But I split it up at what production level is average cost a minimum, and then what is the lowest cost. So this is actually giving us a little more space to write this out. Okay, so plug back in. And I'm going to assume you can use your calculator to get this answer. Okay, so there you go. Now it says compute the marginal cost at q equals 6 and q equals 7. How does this relate to your answer above? Explain the relationship. Okay, so we want marginal cost, C prime, which we had already computed. And I'm going to just write down this little template here from, I'm just grabbing just from above. It's just that you can't see it because I scrolled. But this is what I calculated as average marginal cost. And we have two of these, right? So we just write this twice. And, oh, but we have to calculate it at two different values. Right? So we want to calculate marginal cost at q equals 6 and q equals 7. And then we just crunch these out. And the first one we get 1682. And then we get 1686.28. Aha. See? It should work. And the answer is, it's just from your flexagon. Marginal cost equals average cost when average cost is minimized. Okay, that's all. This thing that was on the flexagon is always the explanation for this question. I hate the fact that it gives me trouble drawing rectangles. Whatever, that's supposed to be a rectangle. Okay, marginal cost equals average cost when average cost is minimized. That's just a little phrase you want to put on your 3x5 card. And that will be the answer to those explanation questions.